This is a video for how to go about designing an original cam from a linear and radar chart graph in Google Sheets and then transferring that information to designing an actual cam in Fusion 360 for your activity 4.1.6 Design a Cam in your Introduction to Engineering Design class. Please note that in the information section below this video there is a link for you to click on where you can make a copy of the spreadsheet you see on the screen and follow along. Where we will be headed in this video is we will be designing an original cam that is not the typical eccentric or pear cam or heart-shaped cam or the hexagon cam that we're used to. And we're designing our own cam based upon what we want this vertical follower to do. So as we rotate this crankshaft, I've made a different kind of cam here, and as I rotate this you'll notice that it doesn't follow the traditional type of motion that we have in our other cams that we've created from other Automata Box videos. So we'll be using some data and designing our own cam and showing how to do that within Google Sheets. So in Google Sheets, down at the bottom of your screen, you will see where I have Cam 1 and Cam 2, and then something called a self-made cam for these tabs. And I'm going to show you how to make linear graphs and how to make radar charts and how to utilize that to help you design a cam. So in order for us to start out, we need to create a linear graph. So we're going to highlight where it says angle of rotation in Cam 1. We're going to highlight all the data you see on your screen, including the titles, angle of rotation in Cam 1. We're going to go to Insert, and we're going to go to Chart. And when we go to Chart, automatically it's going to go to Line Chart. And you can see that our line chart, where we have the angle of rotation down here at the bottom, and we have the height of the follower. And what the height of the follower is meaning is as I turn this crank for that specific cam, that's not the red cam you see on the screen, but as I turn this crank a certain number of degrees, I want you to notice that it references how this cam is moved. So if I were to go, let's say 45 degrees over, we could take the reading from the ruler, and as I rotate over, let's say 90 degrees, I can take another reading from that ruler and then put it in the chart. You don't see that exact same amount of data here, but for where we're headed, we're going to be designing our own cam from what we want the follower to do as far as how high we want it to go. So this is the example of the linear chart we're looking at. When we look at the linear chart, we should get some idea that there's kind of this up and down motion that we see here. Now we need to make a radar chart to get an idea of what exactly is the geometry of the cam look like. On the outside of the cam, what exactly would the cam look like if I was going to go in and make that in Fusion? So we're going to highlight the data again, and we're going to create something known as a radar chart. We're going to go up to Insert. We're going to go to Chart. And once again, it's going to give us another linear chart. We're going to go to Line Chart, and I want you to scroll down until you see Radar Chart. And when we see this radar chart, I want you to note that this is kind of what the cam looks like. It's staying at, almost a height of 2 almost the entire time, but it's going in and out in very small dips. And as we see this curve, this blue line around the outside, it's given us an idea of what the shape of that cam might be. So we have the linear chart and we have the radar chart that's showing us what the shape of the cam would look like. Note that it's starting from the origin here, and it's slowly walking out to show what the displacement of that follower is as we rotate around an axis. So this right here is not a perfect circle. There's some dips in here, but because it's only going up and down a very small amount, I would say that this most likely was some form of maybe a hexagon cam or something like that. So that is what we would have for Cam 1's information. Let's go to Cam 2. We're going to do the same concepts for Cam 2. We're going to highlight angle of rotation and highlight all of our data. We're going to go to Insert, and we'll go to Chart. And for chart here, you can notice that, this one has an all of a sudden drop. And, the example given in the curriculum is of a horse coming up and raising its hooves up and then dropping it back down. That could be, something we have here. There's other stories that this cam could be telling, something that comes so let's say somebody lifting some weights, and it comes up and that weightlifter drops the weights down real fast. That could be a story. Remember, when you're making an automata box, your automata box needs to tell a story, and each one of the charts that you see is telling part of that story. So let's highlight the data again. Let's go to Insert. Let's go to Chart. Let's go to Line Chart. Let's scroll down until we see Radar Chart. And the radar chart here has given us an idea of what that cam could look like. So when we design this cam, we want the cam to actually look a little bit like this, with this sudden drop down to the bottom. So as we're rotating, you can see Let's kind of drag these over here so we can see all of them. We can see that as this starts out at 0, it's staying, right at about 1/4 of an inch out, right here about in between, and then, it's getting a little bit larger. And its highest point is right at about, right before, like, let's say about, 285 degrees, about right here. And then all of a sudden we have a sudden drop back to 0. This is what this cam could look like. I want you to note that this is not necessarily a perfect shape, but it gives us an idea of how to design the cam that we would want to accomplish the task that the story would tell. Now down at the bottom where you see self-made cam, if you have an idea of what you want your cam to look like and how you want the follower to behave, you can start placing those numbers in here, and it would help you get an idea of what kind of cam you would want to create. I want to go back to the example that I have here, and this red cam again does not look like a hexagon cam or like a snail cam or like any other cam that's in the curriculum or what we've created in other videos. This cam is designed to kind of have a bird fly and then flutter its wings a little bit. So the bird moves and it flutters its wings a little bit, and I rotate this around and it flutters its wings a little bit again. That's the story it's supposed to tell. Now I'm going to go to my side view just to give you an idea of what we're looking at, and I can bring this crankshaft up here to the top and call this 0. And we're at about 3 1/8, about 3 1/16, 3 1/8, about right in here, somewhere in between. Close enough is fine. And I can rotate this over and we can approximate where we're at 45 degrees. And we're up to 3 3/16 here. Rotate it over again to 90. And I could take all this data that I'm reading as I rotate it around, what I'm thinking I want the follower to do, and I can go back to my chart and start inserting this data. I want you to note that I'm kind of going backwards here because I already have created the cam, but I'm giving you an idea of what you're trying to predict the follower would do. So if you're saying when I turn it to 180 degrees straight down, I want that follower to be, let's say, at 4. Well, that's part of how your cam would need to be designed, and you can take that number and place it directly into here and go in and create for yourself that radar chart, and it gives you an idea of what your cam would look like. It's not necessarily going to be a perfect shape, but you can take that concept and put it into Fusion, and you can design your own cam in Fusion to accomplish the task that you wish. You will probably have to go back and edit your cam a few times, but in order to accomplish the task that you want to get an idea what the shape will be, you can use the data and use the radar chart. So kind of a process of original design. Original design is not necessarily a perfect process. It takes some trial and error, but the goal is that if you know where you want the follower to be and how you want the follower to behave, remember, the cam and the geometry of the cam dictates the behavior of the vertical follower. So how we go into our chart and say where we want the vertical follower to be, that's going to dictate the geometry of the cam. And we can just go back to our spreadsheet and get an idea of how we want the chart to be. We saw this, or excuse me, the size of the cam to be. We saw this in cam 1 and we saw it in cam 2. If I wanted just a real simple kind of up and down, not a ton of variation, this is just kind of an oblong circle here, if you will. It's not perfect. Over here, this cam is definitely a little bit odd looking, but we could definitely fine tune this to behave the way that we wanted to. Same way in your self-made cam. So I'll leave it to you to decide where you want your followers' heights to be at 0, 45, and 90. But that is what's going to walk you through and show you what type of cam geometry you're going to need in order for your follower to behave the way you want it to tell the story of your automata box. So this has been a video for how to go about designing a cam through the use of linear graphs and radar charts in Google Sheets and Fusion 360.